Alright, I hope you all missed me, but let me talk about the unit circle by myself. So if you have a circle, it's called a unit circle because the radius is just one unit. So which means from the original to the right side, the x-axis, it'll be 1 unit right here. So from the center of the circle is at the origin to any point on the circle, it will be only 1 unit. So here is also 1. On the left will be -1. On the down will be -1 as well. Alright, so that's about the coordinate. So on the x-axis, of course, it will be 1, 0 because the height is 0. The height is the y-coordinate. Alright, so then on this unit circle, we don't just talk about the coordinates, but also the angles, right? Or the radians. So when we talk about the angles and radians, this right point is our starting point. So we are going to start an angle, for example, the one I just draw. It's a 45-degree angle. And then this angle will be counted right here. So here's the starting point is 0. It's 0 degrees and 0 in the radian as well. Alright, 45 degrees, if you remember how to convert from degrees to radians, it will be the degree divided by 180 and then multiply by a pi. So it will be like pi over 4 as radian. Or you can also write it as 1 over 4 pi. Alright, so here's 0. On the top, on the y-axis, it will be, 90 degrees. Because this angle right here, as you can see, is 90 degrees. And 90 degrees can also be written as pi over 2 in radian. So the same thing, you just use your angle, like use your degree, divide by 180, multiply by pi. Alright, so that's 90 degrees. On the left, remember we are going counterclockwise. So from our starting point to the left, this is 180 degrees. 180 degrees is 1 pi because your angle divided by 180, that's 1, and it's just pi. So 180 degrees, or this is a comma, it's not an and or something. So 180 degrees is the same thing as pi. So then going down, here we have 270 degrees. And we can also call it 3 pi over 2. And then going to 2 pi, 1 pi, 3 pi over 2, and we are back to our starting point. So one round of a circle is 360 degrees, or we can also call it 2 pi. I remember, like, there are different names for one angle if they're rotating in different ways. For example, if we go from the starting point, from a negative direction and hit this negative y-axis. Alright, if we go to the negative direction from our starting point to the negative y-axis, it'll be negative 90 degrees. So 270 degrees is the same thing as negative 90, or we can also call it negative pi over 2. So there are different names. Make sure you're looking at the direction, but if we don't talk about directions, we usually use from 0 to 360 or from 0 to 2 pi for a unit circle. Alright, so that's the part 1. Alright, so then let me redraw a circle. Alright, from part 2, how do we call those angles? So for example, if I have a 45-degree angle here, I'll tell you this is 45 degrees. Then we can just call this angle as I said above. It will be just 45 degrees. So if I call this angle alpha, it'll be just 45 degrees for angle measurement of alpha. Alright, but if it's in the second quadrant, so if I know here is your 45 degrees, I should change the color. Alright, if here is a 45 degree. However, remember, our starting point is the positive x coordinate. So we go from 0 to here. That's almost 180 degrees, but we're 45 degrees away from the 180, right? So that angle right here, if I call it, I don't know, theta, if you remember, theta is a Greek letter. So if I call this blue angle theta, angle measurement of theta will equal to 180, subtract that 45 degrees. And that's 135 degrees. And remember, 135 degrees is 3 pi over 4 in radian. These two are the same. And this does not mean division. Alright, so the same thing, that's the second quadrant. Alright, if it's in the third quadrant, so here is another angle. And I know from this angle to the negative x-axis is 45 degrees. And now again, how do you call this angle in green? So again, our starting axis is the positive x. It's a positive x-axis. From your positive x-axis, go to 180 and another 45 degrees. So if I call this green angle beta, so angle measurement of beta will equal to 180 and another 45 degrees. I was just translating my word to a math equation. So 180 plus 45 degrees is 225 degrees. And again, that's the same thing as 5 pi over 4. Okay, now we have the last one. So if I have an angle in the fourth quadrant, just now it was in the third quadrant, and now if I have an angle in the fourth quadrant, and again, we usually talk about from 0 to 360 or from 0 to 2 pi, but it depends on the question. What is the question asking? So if I'm talking about an angle in the fourth quadrant and I know from this angle to my positive x-axis is 45 degrees, then from my starting axis going all the way to this angle, it's almost one full circle, which means it's almost, I didn't give it a name yet, I'll call it omega. Omega. So angle measurement of omega, which is also a Greek letter, equals, it's almost a full circle, and a full circle is 360 degrees. However, it's 45 degrees away from it. So subtract 45 degrees, and this will be 315 degrees, or we call it 7 pi over 4 in radian. So on the left is degrees, on the right is radian, and 45 degrees is pi over 4. Okay. So now let's make a new layer. So from there that's how to name an angle in the unit circle. But we also need to remember, I just used 45 degrees as an example, but there are special angles, which is 30 degrees, 60 degrees, and 45 degrees. and the ratio of those angles. I hope you all took notes on Tuesday, but I'll give it to you again. So you are going to remember the angles, the tricks of 30, 60, and 45 degrees. So here's a 45-degree triangle. I did a pretty bad job, I know. But for a 45-degree angle, as we all know, the angle measurement, the sum of the inner angles of a triangle will be 180. So if I have a right angle, and if I know one of the angle is 45, I can just calculate the other angle, which should also be 45 degrees. And that means it's isosceles triangle. So if I have the segment measurement as 1 unit and 1 unit, I will know the hypotenuse will be square root 2. So then from there, from this picture, I can know the sine of 45, cosine of 45, tangent of 45 degrees. Alright, so here is your angle, and I hope you know SOHCAHTOA. Sine is opposite over hypotenuse. That's 1 over square root 2. Or after we rationalize it, it's square root 2 over 2. So cosine of 45 is the same thing. It's adjacent over hypotenuse. However, it's also 1 over square root 2. So it's 1 over square root 2 or square root 2 over 2. And tangent of 45, tangent is opposite over hypotenuse, over adjacent. So it'll be 1 over 1, which is just 1. Okay, so that's when we call it in degree. In the radian mode, we call it sine of pi over 4. And that's why I was telling you to write the degree sign when we're doing the things in class. That's cosine of pi over 4. Sorry, I don't have script. And that's tangent of pi over 4. Alright. So however, again, in the unit circle, 45, that's not even vertical. Okay. So 45 degrees is only exist in the first quadrant. And when we have a 45-degree angle, which is here, we know the sine, cosine, tangent is square root 2 over 2, square root 2 over 2, and 1. So again, this coordinate on the circle is cosine comma sine of the angle. So this will be square root 2 over 2 comma square root 2 over 2. Alright, now, as I just said, if I have a 45-degree angle on the second quadrant, so as again, second quadrant, your x-coordinate, I should change the color again. So again, this angle is actually 135 degrees. However, it's just a 45-degree angle because we can just make a triangle to see it. Alright, so for this 135-degree angle, we can also find the coordinates. So again, it will be cosine comma sine. And in the second quadrant, as you can see, you're on the negative x-axis. So your x should be a negative number. So instead of cosine 45, which is square root 2 over 2, it will be negative square root 2 over 2. And the sine is a y-coordinate. And y-coordinate in the second quadrant will be a positive number. So it will be positive square root 2 over 2. Okay? Alright, same thing for the third quadrant.